All right. I did tell you that everything that we do in geometry is based on some facts. Facts that we just call definitions, or sometimes axioms, or theorems. We also call them theorems because we accept those as facts. Theorems usually we must be able to prove. Definitions we just define. Like we define a straight line, a straight angle to be 180 degrees. That we're not going to prove. We just decided that that's what it would be. Now there's some theory. Now I discovered that some of you know the theory well because you give very good reasons. Like the first question is, why is AOB a straight line? Well, why is AOB a straight line? Is because of a simple fact. And that fact says what? If one line intersects another line, then two adjacent angles will add up to 180 degrees. So that's a fact. So I think what I'm going to do, I'm just write this now, so don't worry about taking it down. But what I will do for you is I'll probably go and type it, but what should you do? You see, on the basis of these 5 lectures that we're going to have, you're not going to become expert at teaching geometry. You might become good at solving the problem, but about teaching it, you're going to know all the information very well. So you're going to go and find a grade 10 textbook and look up all the theoretical facts in there and get to, to understand it, to be able to illustrate it, and to be able to use it. You must be able to do that. So the first fact actually under lines and angles would be that if two lines intersect, then adjacent angles are supplementary. Now this is always a stimulus. This is something that sets you thinking. So if you see two straight lines,
student, if your name is not there, just add it. Don't worry.
Sure, good. Yeah. All right. So if two straight lines intersect, any two straight lines, this is a fact now, right, that you're going to use. Then any pair of adjacent angles. Now, what's the meaning of adjacent? What? Next to, right. So you two guys are adjacent, isn't it? You two are adjacent as well. Those two are not. You are alternating. But if between me and him, how are we positioned? Are we adjacent? No, we don't call ourselves adjacent, even though I'm going to come very close to it. But we wouldn't call ourselves adjacent. When we describe in geometry, we'll say we are opposite each other. That's positionally, right? We are opposite each other, you guys are adjacent to each other. So adjacent angles, any two, if you pick any two of them, these two will be supplementary. Supplementary is another word for add up to 180 degrees. So that's the first fact, right? The next fact that comes out of here is what? That if two straight lines cut each other, the vertically opposite angles, we call them vertically opposite angles, would be equal. In other words, if that one there is x, then that one there will also be x. This would definitely be 180 degrees minus x, and that will automatically, after the second fact, become 180 degrees. So those are the two things that you meant. What's the stimulus? When you see two straight lines intersecting, those are the facts that must come to mind immediately. Which two facts? That if you pick any two angles that are close to each other, adjacent to each other, they will add up to 180. And if you pick two angles that are vertically opposite, then they will be equal. Can you see? Fact, response. Who's a good geometry student? Somebody who can find every possible response from a given fact. That's a good student. So when you see a fact, it's not just said there for nothing or stated there for nothing. It's a fact which must trigger responses. And if it triggers the faster and the number of responses that you can get to your mind very quickly will determine how good you are at solving the problem. So that question there, why is AOB a straight line? Because the adjacent angles are supplementary. That's the reason, isn't it? Well, you can explain it in detail, don't worry, but it's nice to have concise language in maths, it's useful. But for your sakes, if you just said, well, the two angles that are next to each other add up to 180 degrees, so this must be a straight line because the straight angle measures 180 degrees, you can tell it in your own way. In the next one, AOB and COD are vertically opposite, are they? Are they vertically opposite? Now, this is a bit tricky, eh? Well, we said, what, are they? No. Would you call them vertically opposite? Yes. Why? Why would you call them vertically opposite? see there's a special definition to vertically opposite. They only happen when two straight lines intersect. Are there two straight lines intersecting? Are there? How do you know there aren't two straight lines intersecting? The angles tell us that these are not straight lines. If you thought that that was a straight line, it isn't. Why? Because if you add those angles, you don't get 180. If you add those two, do you get 180 degrees? No. But are these two angles equal? Yes, they are. Which means you don't have to have straight lines to have angles like that equal, isn't it? So they are not, by our correct definition about vertically opposite angles, are rising when two straight lines intersect each other. So just on the basis of those two facts. Now here comes a parallel line, so let's see how quickly we can master all these facts. Now, what is the theory? The theory says that two lines are parallel if two lines are parallel and they cut by a transversal, parallel we usually draw like that, isn't it? Everybody knows the signs of parallel? Who didn't know them at all? And I know exactly when we time to talk about symbols. So you can put two of them if you want, or just one of them is fine. And if it's cut by a transversal, then we describe angles here. A whole lot of angles are formed, isn't it? Now, can we have facts relating to what we just learned from here in this picture? In other words, those facts that we talked about, the adjacent angle supplementary and vertically opposite angles equal, do they apply in this shape? Yes, it does. Why? There are intersecting straight lines. So let's name them A, B, and if we call that E, F, let's make the E here. There it's convenient, and F here. If we name it like that, then immediately we see that A, B, and E, F are straight lines intersecting here at E. Got a different name there. And so automatically these two angles will add up to 180, and so would those, and they'll be vertically opposite angles. But then there's something more special. There's another line which happens to be parallel to AB. So now more interesting things come up. Isn't it? More interesting things come up. Because we've got more angles coming up. Should they be related? Well, ordinarily, maybe not. In other words, if I had any two lines like that, and like that, and I drew that, then we know these angles are all related. Those ones, they're all related. But we're not sure whether these things would be related to each other. Isn't it? But in this case here, when they are parallel, what is the facts that you learned in grade 9 or grade 8 or somewhere along the way? We learned that alternate angles are equal. Now, who doesn't know, never heard of alternate angles? Don't feel awkward to say, I know what I should be talking about. I know school teachers use FUN to describe corresponding co-interior and alternate angles. Any of your teachers use it? FUN? Who heard of that? For in terms of angles, I know you're all about fun. You like that too. So, what do you call it? Anybody use that to describe angles? FUN? I'm assuming only one. Fun. To describe these types of angles. You came across it? FUN? Who did not come across it? Then I know I should talk a little bit more about it and tell you. Mustn't tell you. You want me to tell you? Yes. Well, you see, we describe these angles. Now look, it turns out that this angle here will be equal to that angle here. Right? Why? Because they are corresponding. We just described them. We said this one corresponds to that. What's so corresponding about it? Well, this line and that parallel line, and this line and that parallel line, this is below, that is below, so they correspond to each other. They call corresponding angle. Now, the teachers who teach FUN, they teach it like that and like that, right? Of course, the F's don't have to be like that. And they say, if you've got an F, if you can find an F anywhere in your diagram, whichever way you look, whether you look this way, sideways, whatever, if you can find an F, then you'll get two angles with this F, and those two will be corresponding. So look for F everywhere. So this is an F, isn't it? F? Yes. So there's your corresponding angle. Any more F's? Yeah, you can look on this side. This F is fine too. We can spell F in all kinds of ways. We can write F like that. No, even you. That F is fine too. Oh, these ends too are okay. We'll let's step at this side. We can change that too. We can make it look like that and read upside down. Just become a little dyslexic or something. And the ends also we can change. And the ends also we can change them and make them go upside down. How will they go upside down? Like that. And so you can write in all these ways. Your F can be upside down as well. You know? And things like that. So as long as you can find an F, whichever way you orientate your head, turn it around, look every way, and if you can find an F, you will find corresponding angles. If you can't find an F, you won't find a corresponding angle. Isn't it? You won't. Then, if you want, let's do the last one first, because corresponding angles turn out to be equal. And that's nice, isn't it? What's nice about it is because we know one, you can tell the other. That's why you like equal angles, isn't it? You like equal angles because if I tell you one is 41 degrees, you will conclude that the other one is also 41 degrees because they're supposed to be equal. The last one, the N, gives you two angles, and which two angles do you get? This one here on this corner, and that one there on that corner. And they are called alternate angles. So if you can find an N anywhere, then you go to alternate angles. Do we have an N here? Yeah, that's an ugly, strange kind of N. Here one, that one there. You look this way. Turn your head and look that way, you see an N. And if you can see the N, then this angle here is equal to that angle there. And as many N's as you find, you can see it. Alternate angles are very nice also because they are equal, which means if you know one, you can tell the other. And the middle one, the U, are what are called co-interior angles. Now, I'm not writing these things because maybe I should just write it so you will see it as well. The first I said was corresponding angle. Angles. Second I said was, well, I write the co-interior because of the fun, right? They call co-interior angles. Now, the word co-interior angles, sort of means together, both, company, cooperate, angles, and alternate. Now I described these two here, alternate angles and corresponding angles, but I described the co-interior angles. Co-interior angles are angles that are inside, because you see, if you look at these parallel lines, these things are looking inside and those things are looking outside, isn't it? Interior, inside. So these four angles are interior angles, and those are the angles they are exterior angles. Now co-interior, in other words, both of them are interior angles, and for you to classify them or name them as co-interior angles, they must be on the same side of the transversal. This line here is called the transversal. We call it transversal because it cuts across the two parallel lines, but it cuts across any two lines, we call it transversal. So that line is called a transversal. And on the one side of the transversal, you've got two interior angles, that one there, and that one there, and they will add up to 180. They are supplementary, they will add up to 180. So those are the three facts. Now see, it looks like a lot so far, but you just absorb them and they get into your head and they stay there forever. Right? So what facts do you know? If two lines cut each other, you'll have adjacent supplementary angles, you'll have vertically opposite angles. If there are two parallel lines that are cut by another line, then you will have corresponding angles equal, yeah? Co-interior angles, supplementary, and alternate angles equal. So on the basis of that, we can answer this question. Equal alternate angles, which would they be? Alternate but equal. Okay, let's get the picture. The first thing, the biggest mistake that everybody makes in geometry is that they don't study the picture. Let's study this picture. What do you see? A whole mass of lines, isn't it so? Anything special about any one of the lines or any pair of the lines? Are there any lines parallel? Yes, which two? AD and CD. No, it's DC, right? You normally have to make them in the same direction. That's not very important. So BA and CD are parallel. Are the other two parallel? No, they're not parallel. So those two are parallel, which means we can find some angles that are equal and some angles that are supplementary. Right? So we can pick them out. Which ones would be equal? The corresponding angles and the alternate angles. But now there are also two other lines there. What are they? Are they parallel? No. Alternate angles and corresponding angles and coincident angles. Yes or no? Yes, there would be. But what would be the difference? The difference is we don't know any properties about them. We don't know anything about them, like this picture here. There are corresponding angles, you get your n, a crooked n of course, but you get one. Right? You get the n there. Right? See? Like that. You get the f. You get them all. But we can't say anything special about them because those two lines are not parallel. So here we got parallel lines. So now answering those questions, equal alternate angles, well, which ones would they be? Name them. AN, E2, and E2. Right? Isn't it so? Where's the N? There's the N. Isn't that it? Right. The next question. Unequal alternate angles. So now you're going to look for which? Non-parallel, isn't it? Non-parallel. Which ones? That one and that one. So it'll have to be E1 and C2. Okay, that's easy. Equal corresponding angles. That easy? Which is it? B and C2. Yeah, there's there. And these ones are parallel. Unequal corresponding angles. Where's another F for this two parallel lines? C1 and E2. How about co-interior supplementary angles? Yes? Co-interior supplementary. They must be supplementary. Which did you say? A and B and C1. Any others? A and E1 as well, isn't it? Parallel lines, that one and that one must be two transversal, you see? Yeah, so those are supplementary. Non-supplementary? Which one? E1 and C1 and also A and B, isn't it? So then you see, those are already, if you know all that, you know a little facts, right? So that was up to the third one. That's why we had to talk about this one while it's parallel lines, or you want me to just do it on your own? But I think you've done it already anyway, some of you. Now, this is a very, very useful thing in geometry. Because very often you have to prove two lines to be parallel. For a variety of reasons. You want to prove that two lines are parallel because you can discover some other facts about it. So, the question asks, why are A, B, and C, D parallel? Now, this is what we call the converse of a fact or a theorem. Now, this theorem says that if two lines are parallel, then the alternate angles will be equal, corresponding angles will be equal, and the co-interior angles will be supplementary. Isn't it, if two lines are parallel? But if you want to prove that two lines are parallel, what do you have to do? Just find two angles which are alternate and show that they are equal. Then you're done. Or find two angles that are corresponding. Isn't it? And show that they are equal. And then you're done. Or find two angles that are co-interior, add them up and see if you can get 180, and then you're done. Right? In this case here, why are A, B, and C D parallel? Because what kind of angles are equal? Alternate angles are equal. You see, this one here is equal to that one, and they are alternate angles. Can you see? So these two lines must have been parallel. If not, where would alternate angles be equal? In other words, in this picture here, if I told you that this was y and that was y, I told you they're equal, then you will conclude that I drew my lines badly. Isn't it? Why? Because those lines should have been parallel. Isn't it so? Yeah, that's what you will say. But of course I didn't intend for them to be equal. The next one, BC and EF, are they parallel? BC, the first one was CD and AD, right? Next one, DC and EF, are they parallel? Yes. Why? Corresponding angles. Right. AD, so the next question is, why are AF and BE not parallel? Which is AF? AF and BE, why are they not parallel? Don't tell me because they don't look parallel. What's the reason? You must give a mathematical fact as to why they not a visual fact. Why are they not parallel? Why? Yeah, let's see, anybody?
Define the angle of A, and you say angle A is not equal to angle B, they are unequal corresponding.
In other words, the corresponding, your main fact is that the corresponding angles are not equal. Right? He says the corresponding angles are not equal. In other words, he's making a claim. He says corresponding angles are not equal. But there's only one pair of corresponding angles for this line and that line. Which is that pair of corresponding angles? Which is the pair of corresponding angles? Well, if these two, if we at all wanted to prove that AF and BE are parallel, which will be the only two corresponding angles? A and is 53. Is that right? A and 53 will have to be the corresponding angles. Now he claims that those corresponding angles are not equal. Do you agree? Do you agree? How? What makes you say that? Because you can calculate A. Now what did you find it to be? You found it to be 75. Now who doesn't know how they arrive at 75? Who knows how? Come on. Tell me, you know how. Who doesn't know how? Who is still thinking about it? Well, what would be the reason for this to be 75? It's co-interior with this. Because these lines are already parallel. Didn't we say so? We said they are parallel. So these two lines are parallel and those two must be supplementary, which means if that is 105, that must be 75 because they add up to 180. So that's 75 and that's 53. They're supposed to be corresponding. Yeah, they are corresponding, but they're not equal. So those two lines must not be parallel. So you see, it's not a question of what you see, it's a question of what you can argue. Right? Everything in this kind of maths is information. What are the responses? In other words, what's the implication of that information? And you present an answer.
But we can also show that they are not parallel because without doing any other calculation process, wouldn't it be easier to just take those two angles?
That would have been enough. Yeah, that's
Without doing any extra work.
No more work. See, that's
If you just look at that, they are co-interior, right? But they are not supplementary.
Yeah, that was much
Okay,
easier.
that would
Thank
be
you.
easier.
Definitely, no more working. Right? So, what's your name? You came up with this, and it was a very nice thing. Of course, you like. Obviously, he likes corresponding angles, right?
Yeah.
Now, if you saw co-interior angles, no working at all, right? Just see it; they don't add up to 180, so it can never be parallel. Thank you for